Good evening, sir.
Yeah, very good evening to everybody. So today, first of all, what I would like to show is that what basically we do with the help of this remote sensing and GIS. And from that, I think you may generate some idea regarding your work in future. I mean, some of the things have been discussed regarding the processes in raster and vector formats. But still, I feel that to have a better exposure of it, I'll be showing some of the things that we do. Mainul, who has been consistently dealing with it for the last 3 days. So first of all, let us see that what can we do with this. I don't know what are the things that may come to your requirement, but maybe some of the things. I mean, there are several doctors over here, almost 80, 85 doctors or 90 doctors may be here. So different doctors may be working in different field, and some of the things may be helpful for them. So I'd like to show you some basic things. So I've opened a lot of PPTs today to have a better exposure. So first, let me start with this. Well, the first day, as I explained, that remote sensing is the fundamental science that we deal with. So it has 3 basic components. One is the remote sensing. That is a process of detecting, monitoring, or any physical characteristics or interpreting anything without being in physical contact with it. GIS, what we have been dealing with the last 3-4 days, specifically creation of polygons, vectors, points, lines. And again, the second half of this class will be consisting of doing some geospatial analysis on that. So GIS is basically a computer system for capturing, storing, checking, and displaying data with respect to the Earth surface. And finally, the GNSS, which is commonly known as the GPS to us. Even our mobile phones are having inbuilt GPS right now today. So let us see that what we can do and what are the fundamental processes that we should know regarding this remote sensing. This is already shown to you. This is the electromagnetic spectrum because in the very first day I told you that the sun rays come, hits the surface of the earth, gets back to the satellite. The satellite captures the data. We fetch those data and then we analyze and interpret on the basis of that particular data. So for us, data is basically the wavelength. For us, data is basically the wavelength. So if we look at this particular, first of all, is it visible now? My screen is visible to everybody, I hope.
Yes, sir.
Okay, thanks.
Yes, sir. Yes, sir.
Thank you. So this is the electromagnetic spectrum. Okay, it starts right from gamma rays and into radio waves. So electromagnetic spectrum consists of gamma rays, X-rays, UVs, visible spectrum, which is the VGO, then the infrared and the radio waves. But the interesting thing is that whenever we take a photograph, say for example, I'm taking a photograph with the help of a camera, I'm taking a photograph with the help of my mobile camera, whatever may be, the part of the spectrum that we basically capture or we are able to capture is only the visible spectrum, that is a VGO, only this VGO part. So the photography is restricted to 0.4 micrometer to 0.7 micrometer, or if you say specifically, it goes on to 400 nanometers to 700 nanometers. So that is the wavelength that we can capture with the help of a camera. A camera does not have the capacity beyond this. But what happens in case of a satellite image, say for example, my smart slide, if it is showing the satellite, or say a lot of browsers are open in my over here. Say, for example, this is a browser, and we can see these are the images of the satellite getting the data of the surface of the Earth. So this is how the satellite takes the data of the surface of the Earth. And what we specifically gather, that is the satellite can gather the data from the whole electromagnetic spectrum. It's not restricted to only photography. In case of photography, it's only the visible band. But the satellite can capture the data from the whole electromagnetic spectrum. Okay. So this electromagnetic spectrum, the satellite sensors are designed in such a way that it takes some discrete data. Now see, over here, it is a satellite image. It is a satellite image. On the final day, we'll be having an assignment, and the second step is we'll be showing the sources of data. Okay. So in order to understand that what to download, you need to understand this class. So whenever we'll be migrating to a browser or a portal, whatever, and we want to download some data, so the satellite will give us some data like this: band 1, 2, 3, 4, 5, 6, 7, 8. A number of bands can be there. And these bands would look like this. Okay, the band will look like this. They will be in black and white color, I may say. Actually, these are nothing but a simple wavelength being captured. Say the first one is, say, the blue band. The second one is the green band. Third one is the red band. Fourth one is, say, the near infrared. Fifth one maybe the TIR, that is a thermal infrared. So this way the data are being captured. Now a red band doesn't look red, or a green band doesn't look green, or a blue band doesn't look blue actually. So they look like this black and white. And due to the radiometric resolution that I told on the very first day, that these are nothing but some digital numbers, because computer understands some numbers. These are some digital numbers on the basis of the pixels, and we download those data. Now, in order to analyze in our computer or in our workstation, again, the computer has a limitation. The computer has a limitation, that is, the computer is able to compute 3 bands at a time. That is red, blue, and not actually red, blue, green, but the computer has the ability to visualize this red, blue, green. And on the basis of different permutations and combinations, it will give you different colors. Now, what we do is basically that we fetch the band that we need, that we require, and we do it with, we just pass these bands through filters. These are known as filters, which are red, blue, and green. That is the computer which what enables us. And then we finally get an image. Okay, I'll get back to this. But before that, I'll be going to some other slides so that it is easier for you to understand. Now, whenever we capture these images, this is a known thing for you, I hope. These are some X-ray plates being combined. Whenever we capture these images, there are a lot of things that are going on in a lot of processes. Number 1 is reflection. Number 2 is refraction. Number 3 is emission. So, a lot of thermodynamic processes going on. So, in order to make the image readable, or in order to make the image understandable, we do some mathematical calculations. Some mathematical algorithms are being applied. While doing an X-ray, also in an X-ray machine, there are some algorithms being applied in the particular software. With the help of the software, what we basically do, we basically increases either the brightness or the contrast of this to get a proper image of a blur image after capturing the data. So again, my data over here, whatever we are capturing in case of an X-ray also, that is an wavelength only, nothing else. It's just an wavelength. So what we actually have while we deal with an X-ray plate, while dealing with the mean and dealing with the brightness and the contrast. So the brightness is basically the mean, the mean radiometric value that you are getting. Okay. That is it is understood as the brightness. That is, what is the amount of the light being reflected. So the mean of that is known as the brightness. And statistically, if we understand what is the standard deviation, so that is being defined as the contrast of that particular X-ray plate. And we make it a better one, or a very readable X-ray plate from a blur image just by adjusting the contrast and the brightness. So it is statistically, we adjust the mean and the standard deviation of the data. Next, say for example, if we have a data like this, say the figure A can be converted to this one, say figure C. How to do this? Again, the same thing can be applied in these X-ray plates also. This is known as this process is known as linear stretching, where we adjust the mean and the standard deviation, or the brightness and the contrast. In the same way, say for example, whenever we are having maybe a television set, maybe again X-ray, or I don't have any idea regarding the USG monitor, but most of the monitors that you deal with have a bit system. Okay, have a bit system. Say for example, we have a 8-bit image. We have a 8-bit image. So the 8-bit image is actually equal to 2 to the power n, or we have 4-bit image, so it will be equal to 2 to the power 4. So in case of a say 8-bit image, if it is 2 to the power 8, so it is 2 into 2 into 2 into, so multiply 2 8 times, and we get a data like 256. So if it is a 8-bit image, say for example, hypothetically, I'm considering that you are dealing with a particular medical instrument which is 8-bit. If it is a more, I mean, if it's a better quality medical instrument, it may be 10-bit, 11-bit, 12-bit. So it depends on the bit. That is, it depends on the radiometric resolution. So what we do, primarily we capture the data. Primarily we capture the data. But if it is an 8-bit image, as I was giving the example of if you want to shop and want to buy a blue shirt, for example, and if it's a 8-bit data, so the shopkeeper is supposed to provide you with 256 shades of blue, starting from the very dark blue to almost the whitish blue. So what happens, whenever we capture the data, the instrument sometimes capture the data within its limits. So in case of a 8-bit image, we can stretch the data right from 0 to 256. Sorry, 255. But sometimes it takes the data within it. But then what we do, the software has the capacity of stretching it. This, say, for example, this data is around 170. So we stretch it from 170 to 256. And this data is, say, 76. And we stretch this data from 76 to 0. Now it becomes like this. So once it becomes like this, the picture will automatically convert from here to here. So it will be a better readable picture. Same for this linear stretching. You can go for an increasing the brightness, you can go on increasing the contrast, and again you can apply these processes, which in our software environment is known as histogram equalization. So this is how we bring about the clarity of the particular images. Images are nothing but the stacking of these bands. So once you stack these bands and filter them through blue, green, and red, you get a particular image, and it depends on how better the image is. And now with these particular images, so basically you can understand these images are made up of pixels. So this is going to be a raster data. So the first day we talked about the raster data and the vector data. So the vector data mainly consists of the point, line, and polygons, but the raster data consists of the pixels. So the raster data is mainly generated from these satellite images. Upon this raster data, we work out with the help of this GIS platform, to have different types of spatial analysis. Now we take up an example. This is the map of Kolkata. Okay, this is the map of Kolkata. And what we can do with this? Say we are doing all these things. I'm telling you every day that we can have a lot of data from the satellite, this and that. But what we actually can do? Say for example, this is a map of Kolkata. Not example. This is actually the map of Kolkata. And then what we have done, we have taken an image like this. So the images are basically rectangular in frame. So once we have taken this image, Moinul will today show you how to subset or clip. That is, you have taken a full image, and from this image, say somebody lives in Mumbai, or somebody lives in Bangalore or Chennai or Chandigarh, or wherever maybe, and he want to work out regarding the particular city, say Chandigarh or Mumbai or Pune, wherever. So you ought to have the polygon feature. You have learned how to create the polygon feature. And after creating the polygon feature, go to the clip function. When will show you today? I'm just giving you a brief of that. And you can just subset that particular image. So the image was basically rectangular. But Kolkata is not rectangular. Kolkata has got a definite shape of its own according to Survey of India. So what we did, we created a polygon for Kolkata, and we just subset, or we clip. We technically we call them clip or subset. That is, we just masked out Kolkata from that particular image. So this particular image now is image of Kolkata right now. And every image has a particular date of pass. The absolute date of pass is over here. The date of acquisition is 31st of March 2019. So this image has been captured on 31st of March 2019. It is a sentinel image. The pixel size is 10 meter by 10 meters. So one pixel will be around 100 square meters. So what we can do with it, see, we can do a very simple thing. We can apply a very simple algorithm to get the land use land cover pattern of this particular area. Okay, so let me show you that. So this image actually gives you, just applying a particular algorithm, I promise you it will take around 5-10 minutes, and you will get the complete land use land cover map of Kolkata. So this is a complete land use land cover map of Kolkata, and these are some indices like the red area actually represents the built up area. That is, there are roads, houses, hotels, and buildings. So everything which is built up is the red area. The green area are the vegetations. That is, there are some trees and plants over there. The blue area are the water bodies. So these are the water bodies present. And the rest of the area, which is denoted by the yellow color, are the fallow lands. So you will be getting a particular land use land cover map of Kolkata on that particular day, that is 31st of March 2019. And this is the whole map of Kolkata. Now, if you want to prepare a particular this land use land cover map on this particular day, that is 24th of February 2025, what you can observe is that what are the changes that are taking place? Is the built-up area increasing over a period of time? Is the vegetation decreasing, or is the water body increasing, or is the water body decreasing? So whatever kind of data you want to fetch from this particular data set, you can get it. So my data was nothing but wavelengths. So this was my data. That is a satellite image, which I have downloaded from portals. I have just created a polygon. I have subsetted Kolkata from that particular proper image. I have derived this Kolkata, then I'll applied some algorithms in a particular software environment, which is QGIS for you. And then we have got this image, okay? And then we have got this image, which will give you the land use land cover map of Kolkata. And interestingly, it is being seen that mostly Kolkata is a built-up area. It's very built up. So it's very obvious that the heat over here is going to be very high. So even with this particular image, not this particular image, but even using some of the bands, we can prepare the LST map of this particular area. That is the land surface temperature map. So what is the land surface temperature in the month of May, and what is the land surface temperature in the month of October, or maybe December, or maybe January? You can get it. I mean, you can perhaps relate it with some medical parameters. That is, the temperature increases by these, well, these are the diseases that may come in if the temperature remains in the normal. Say, for example, in the month of May, the normal temperature should be 35 degrees Celsius, say, for example, in Kolkata. And we are seeing that after analyzing this data, we are seeing that the temperature, the mean temperature of Kolkata is around 42 degrees Celsius. So there has been a difference of 7 degrees Celsius in Kolkata in the month of May over a period of time. Climate is basically nothing but taken as an average of 30 years. So for the last 30 years, say, for example, if you have an average temperature of 35 degrees Celsius, that this year, coming May 2025, you have a variation of the temperature, say, by 7 degrees Celsius. So that is a positive 7 degrees Celsius. And maybe some medical parameters are disturbing some of the people in that particular area, or maybe due to the heat conditions. So you can very easily correlate that, well, these are the temperature conditions that are staying over here consistently. And maybe these are the problems that are arising, the medical problems that are arising out of this. Maybe, I don't know, but this can be done. And now we can create some very normal statistical diagrams from here. So this is a normal bar graph. Kolkata has around 144 words. So this bar graph shows that what is the percentage of the built-up area in this area. So some of the wards are having almost 100% built-up area, 100% built-up area. Just imagine. So this is the situation. So what we can do is that we can fetch this data sitting at your home. You don't have to go outside. Sitting at your home, download some data from the portals, get your software, process it, you get it. So the next thing, say again, this is an image. I was working on a floodwater harvesting system. So this is an image of an area. Now this is an image of an area which is completely urban in nature. Now this is an image of an area which is rural in nature. Now, as I was speaking of subsetting and clipping, so what is this? This is an image of an area which is completely urban in nature. Now, this is an image of an area which is rural in nature. Now, this is an image of an area which is completely rural in nature. So what is this? This is an image of an area which is completely urban in nature. Now, as I was speaking of subsetting and clipping, so what is this? So basically, this is an image. This is an image. This is the Ganges, okay? This is the Ganges or the Ganga, whatever you call. And this is another river known as Damodar. And this is an area. This is again an administrative unit, Pandua. And I want to subset that. I want to subset that from this particular image. So this is basically how our image actually looks like. A satellite image actually looks like. Now I have created this polygon and I have overlapped that. The process is known as overlapping. So there is an image and you have overlapped the vector over there. So the primary thing was the raster, and then I have overlapped a vector over there. And what I can fetch from here, after just subsetting C, I've just got the image of that particular area. Similarly, I've got the image of Kolkata. Okay, I'm repeating, I'm showing it. So this was primarily the image, and this is a vector that I've created. That is a polygon layer I have created. And I want to subset this particular area only. I don't want the full area to be analyzed. I want to analyze only this area. Say I'm a doctor of this particular block or taluk or subdivision, whatever, and I want to analyze this particular area. So what should I do is that I should subset it. I should subset it or I should clip it. So once I clip it, I'll be getting the raster like this. So once I clip it, I'll be getting a raster like this. And now again, you can do a lot of things with this. Again, but I'll be showing you the same thing that I have shown you for Kolkata. Again, we are going for an image classification. Once we do an image classification, we'll be getting the land use map of this area. Now over here, when I'm classifying this rural area, what I'm getting, these are the green patches are agricultural areas. Again, the built-up areas are the red patches. See, the red patches are very low. So the built-up area, this particular block is very low. Then the very deep green areas are the vegetations, that is plantations and trees. Next is some of the sandy exposures are there. There is the agricultural fallow. So this image was actually captured in the month of November 2011. So mostly the crops are being harvested. So we can show that we can see that most are agricultural fallows. Otherwise, if the image has been taken in the month of June or July, it would have been completely green. That is, it would have been agriculture. So over a period of time, say for the different seasons, also will give you different data. So if you take a data in the month of July and if you take a data in the month of November, that will also help you to fetch different kind of conclusions and results. And next, again, the blue areas of the water. And these are the statistical conclusions that we can draw. The image will also give us that what is the percentage of area and what is the square kilometer. The image will not only classify it, it will not only classify it and you can visualize it. It's not like that. It will also give you the data, that is, what is the percentage of the area under agriculture, under built-up area, under vegetation, under sandy exposure, under agricultural fallow, water body, etc. So it will give you the complete data. Okay. Now coming to next words. So these are say if I don't know if anybody is working in the field of fluorine, fluoride contamination or arsenic contamination like this. So these are some data. These are prepared in another district of Bardhaman. So here we prepared the maps of I and Manul both. In fact, Manul has prepared most of them. These are the maps which show the static water level of that particular area. Okay, the static water level, that is the water level, whatever the water level is. And see, we have created these maps for different time. So what is the static water level fluctuation from 1996 to 2000? What is the fluctuation in the time of 2000 to 2001 to 5, then 2006 to 10, then 11 to 15, and then 15 to 20. So we can find out that whether the water level is going down or whether the water level is going up. And we can just, on the basis of that, we can identify that whether a particular area may be affected by things. Say, for example, I'm saying, I'll be going to the next diagram and maybe I'll be explaining it better. So this diagram again you can see, and see this is the pre-monsoon static water level and this is the post-monsoon. So just after the monsoon, what is the water level, and just before the monsoon, what was the water level? And after preparing this map, what we understand is that whether the water level is going down or not. Why it is required? Say, for example, we are working in a community medicine, and in West Bengal, specifically in any areas where there is Gangetic alluvium, there can be problems of arsenic. Now, how the arsenic came up? Previously, there was no problems of arsenic. In fact, people after the Green Revolution basically started fetching a lot of water, So what happened is that the water level, the groundwater level basically went down. So once the groundwater level went down, so if there cannot be any void space in the soil, So once the groundwater level went down, the normal air improved into that particular area. So the air is consist of basically nitrogen and oxygen, and obviously some parts of carbon dioxide and trace elements. So due to a particular geological pressure, what happened, this arsenic, which was actually with a ferrous component, this got oxidized in the presence of oxygen and due to that particular geological pressure. And so once it got oxidized, this ferrous component converted into the ferric component. Now, this arsenic with this ferrous component was actually insoluble in water. But what happened, once it got oxidized, this ferric component released these arsenic oxides. And these are actually highly soluble in water. So what happened when during the post-monsoon, when the water level went up, so this arsenic oxide actually was soluble in water. And once we got pumping the wells, the arsenic came out. And people started drinking the water which contained more than 0.05 milligrams of water per liter. So certainly in areas of some areas of West Bengal, people started facing the problems like Blackfoot disease. And then only the research started over there. And we found that people are drinking arsenic above the limit. People are drinking arsenic above the limit. So this is some geological procedure what is taking place due to the difference of the water that we are drafting. The same happens with the fluorine contamination in some parts of West Bengal also. So when we are doing this, if you are doing any kind of research that why is a particular problem arising in a particular area, it's not, say for example, if people are having fever and everybody is having fever all over India, it's not an issue. But the Blackfoot disease is not a disease which takes place throughout India, I promise you that. Well, your doctors will be having better data for that. But these Blackfoot diseases are the diseases which only takes place in the areas where there are mostly alluvium containing this arsenic. So once people start drinking this arsenic above the permissible limit, which is soluble in water, then the problem starts. Again, I can promise you that this arsenic is not found in the surface water, because it is a geological pressure which acts as the catalyst for the reaction to proceed. It is a geological pressure which acts as the catalyst for the reaction to proceed, that is from the ferrous to the ferric component, where the oxidation actually takes place, and arsenic becomes soluble in water and you take up. So these are the problems which you can use this geospatial technology to correlate facts and figures. Next, again, say for example, this is the seashore area of West Bengal. And what we can do, again, with the help of the GPS, we can just walk through the beach of the, we can walk through the high tide level, and we can see that what are the changes of the coastline and the shoreline, etc. And again, there may be saltwater intrusion through that, and again from the saltwater intrusion, if the beach is migrating towards the land, say for example, there may be saltwater intrusion. I don't know whether any of you are walking in the very near coastal areas and they are facing the problems from the water they are fetching from the ground. If they are fetching from the ground, there may be saltwater intrusion and they might be facing some problems. Okay, so these are the kind of things that we generally do. Another thing I would like to show you just is this one. Well, this was a presentation prepared by Manul. But a few things I would like to show you. Say, once we get all this data, say, these are some data which are not related to you, might be. These are total irrigated area, total area under crops, total what is the amount of the water which are fetching, total vegetation, etc., etc. Now, what I'm showing this data to give you some idea of what we can do. We can prepare some bar graphs, that is very natural and normal thing. But what we can do, see, this is a statistical method which is known as the principal component analysis. So here are, say, a lot of factors, a lot of variables: rainfall, evapotranspiration, laterite, salt, silt, young alluvium, old alluvium. So similarly, you can have a lot of parameters while dealing with a lot of patients, and do you want to find out that what is the particular thing that is hampering this particular patient. So we can have a lot of parameters, and we can go for factor analysis, we can go for principal component analysis, and we can find out that what are the factors. If we are going for a regression, that is a different thing. If we are going for a correlation, that is a different thing altogether. But again, if we are interested in finding out that what are the real factors that are playing the role in this, then geospatial analysis can be a helpful tool for you. Okay. Uh, so these are a lot of statistical works that we have done, or these are some of the parts of Manul has done, in fact. So let me hand it over to Manul. If you have any question, you can just go through, or you can ask me that whatever I have told. But otherwise, I will hand it over to Manul, and he'll be showing you that what are the, I mean, I've shown you something that how to perform this geospatial analysis using these vectors. If you have any questions here, I mean, please get it. Manul, it's up to you. You just start. Manul, can you hear me?
Yes, sir. Yes, sir.
Okay, and stop sharing, and you start
Okay, sir.
vector functions.
Sir, is it visible? Is it visible, sir?
Yes, Suttu.
Yes, yes, visible. Visible.
Okay, sir. Thank you. So now, in today's session, we will learn some advanced geospatial analysis. For example, first we will learn how do we clip a particular study area or any geometrical shape from a raster data set, right? So to do that, first you have to import the raster data set and your study area, what you want to clip from this raster data set. So first I will import the raster data set or satellite images that I want to clip. So for that, you have to import the raster data set, and I have a raster data. So basically, this is a list 3 image, list 3 satellite images, and there are 4 bands are there. So if I transparent the other areas or other portion of the images, then go to the transparency option. Just first right click on this layer, then go to the transparency option, and then add some values like 0 to remove this black portion, right? And I will make it white. Yeah. So now the black portion has been removed. And from this satellite image, I will extract or I will clip my area of interest. So to do that, first you have to import your vector dataset. So I have a vector dataset with me. I am importing this data. And I have already shared all the dataset that we have used in today's class. Yeah. What happened? Just a minute. So suppose if I want to create a area of interest above this layer, just I'm creating it. Okay. So to create a geometric layer, you have to go to the layer option and then create layer. From this create layer option, just go to the new shapefile layer. And here you just provide a name. So now I am providing a name for this particular layer, extraction.
Sir, sorry, sir.
Okay.
Sir,
Extra-
excuse me, sir.
Yeah, yes.
Sir, this band stack raster is not shared, sir, with us.
Okay, okay, sir. I'm just here. Yes. So now I am creating a vector shape file from the layer option. Just go to the create layer option and then new shape file layer. Provide a name. So I am providing a name that is extraction. Select the geometry type. Here in this particular case, I will use polygon. Then again provide a name. So I am providing a name of extraction. Add to the field list and then click on OK. Now one shapefile layer or one vector layer has been created. Just highlight this layer and click on this toggle editing option. Then select the add polygon feature and start digitization. Like this. And then at the end, just click on right click, provide a ID number and then click OK. Now a shape file or polygon file has been generated. Just save it. I make it hollow. So to make it hollow, just go to the symbology option and then so now this particular shape file has been transferred. And I am clipping this particular study area as this particular extent is my area of interest. So now to do that, just go to the raster option. Then from the raster option, there is an option called extraction. Then from extraction, you just click on the second option, clip raster by mask layer. So select the raster layer, that is the list 3 image, and the mask layer here is extraction that I created. The
Sorry for
polygon.
interrupting. Have
Yes,
you
yes,
shared
sir.
band stack raster? Where is it? I don't see it on WhatsApp.
Yeah, I will share it.
Yeah, because we can't follow without that. So
Yes, sir. I am sharing it. it will take some time because the size is quite large.
So,
So
sir,
are
it
you
would
sharing this particular raster?
Yes, sir.
It will take a long time. Okay, do it.
I'm just sending.
Okay.
and also, sir, once you share, if you could restart this demo, that would really help so that we can
Yes,
follow.
yes, sir. Yes, sir. I will do it.
Thank you.
Yeah. So first I will repeat the entire process. So first, you have to import the raw data that you want to clip or want to mask on the basis of your study area or on the basis of your area of interest. So just import the raw data or satellite images, whatever you have. I'm sending it. And for my computer, this data is available in this particular folder. So I am just adding it. Yeah. So now this particular satellite image is open in QGIS environment. Now you have to remove this particular black portion. So to do that, just click on this, make a right click on this layer option, and then go to the properties. From properties, there is an option called transparency. So from transparency option, just provide 0 to no data value and display no data value as, just make it white. And now the black portion of your image has been removed. Then on the basis of your study area or on the basis of your area of interest, you just have to create a particular polygon layer, or if you have any polygon layer with you, then on the basis of that polygon layer, you can clip it. Yeah. I'm checking whether the data set just a minute. Yeah. So now on the basis of this particular polygon layer, if I make it more visible, then just provide the color. Yeah. So this is my area of interest or the polygon layer that I have created to clip that particular portion of the satellite images. So to do that, first you go to the raster option. Then there is an option called extraction. From extraction option, just go to the clip raster by mask layer. Then from here, just provide the input layer. For in this particular case, the input layer is band stack raster or satellite image that I have with me. then provide the mask layer on the basis of which you want to extract or you want to clip. So this is the study area or area of interest layer that I have created. Then no need to provide any other thing, just save it in a folder where you want to save and then click on run. Now the process is getting completed and this particular portion of the satellite images is extracted. So now if I go to the properties of this particular layer and then again go to the transparency option, provide 0 value for no data value and make it white so that the black portion of the image removed. Yeah. So now on the basis of the polygon or on the basis of the extraction layer that I have created, our satellite image, that is the least 4 image in this particular case, I have extracted it on the basis of this extraction layer. So in the same way, you can do it. I am just sharing the data set with you. Actually, this is a quite large data set. So, and that is why it will take some time. So now I have shared it in the group. You can download this data and follow the steps that I have already provided. So if I again repeat this process, just go to the layer that you want to extract. So first you have to import the satellite images, and then on the basis of the study area or on the basis of the area of interest, you can easily extract or clip any portion of the satellite image. So just you have to go to the raster, and then from the raster option, go to the extraction. From extraction, you just provide clip raster by mask layer, and then provide the input layer as the satellite image, mask layer. In this particular case, it is extraction, and save it in a particular folder wherever you want to save, and then run. So it's a very easy process. You can do it very easily by using few clicks. And then after, when the processing is over, just go to the properties option. From properties option, go to the transparency, provide additional no data value as 0 and make it white so that the black portion of the image is removed. Yeah. So now this is the particular portion of the satellite image that I have clipped on the basis of extraction layer. Now, the next thing that we will learn in today's session, we will use some geoprocessing tools.
So can I ask a question?
Yes, sir.
Instead of using an extraction layer,
Yes.
what if you have the entire map in front of you and you want to clip it on the spot without using any other polygon? Can you draw a polygon on this and extract it also?
Yes, you can do it. You can draw a polygon and you can extract the portion of your polygon from the satellite images.
Okay.
Right. So if you want to draw a polygon, again, I have shown you in the previous class, just
Right.
go to the layer option. From layer option, create layer, create new shapefile layer, and then provide a name. if I creating a shape file, extraction 2, if I provide a name of extraction 2, then just select the geometry type polygon. Here provide a name AOI, then add to the field list, click on OK. Now another shape file has been created, and you just go to the toggle editing option, click it, select the add polygon feature option, and start digitization. Whatever portion you want to extract, you can digitize. After digitization is complete, just provide a value 1 for ID and save it. Now another polygon has been added, and on the basis of this particular polygon, you can extract the information from the satellite images for this particular polygon only.
Okay.
Now,
Thank you.
I am coming to the next step, that in today's session, we will learn some geoprocessing tools. And to use the geoprocessing tool, you just go to the vector option. And under vector option, there is an option called geoprocessing tools. Under geoprocessing tools, there are several other options: buffer, cliff, dissolve, intersection. So these are the different geoprocessing tools that we use for spatial analysis. So if I introduce each of the geoprocessing tools that are available in QGIS. So first, buffer. So buffer is basically, we use buffer to identify the area of influence of any particular object or any particular geometric feature. For example, if you want to study the flood-prone area of a particular river, then you can draw a buffer around a particular river. You just have to provide a particular radius. Suppose if you want to create a buffer around a highways and you want to study the surface area around a national highway, then in this particular case also, you just have to provide some sort of radius around the national highways and a buffer layer has been created. So now if I explain it through software, just go to the buffer option and then provide an input layer. So here in this particular case, first you have to input the layer that you want to create or you want to use for buffer layer. Just import the dataset. So I am importing. First of all, I remove this one because it will make confusion. Yeah. So I have a point layer with me, and on the basis of point layer, I will make buffer around it. So a point shape file, that the location of hospitals. Now I am adding this shape file to my QGIS interface. Now go to the vector option. From vector option, go to geoprocessing tools and then buffer. So under buffer, there is a option called input layer. And now here in this particular case, the input layer is hospital. That is basically a point layer. And you have to provide a distance. You have to provide a value, right? So if I provide an arbitrary value like 2000, and there are several other options called segment, end cap style, you can personalize by using these options. But for demonstration purpose, I am using the default one and just click on run. Now, for each of the point, a buffer has been created. And the distance that I have provided, that is the 2000 meter, right? So again, if I create another buffer, Yes. So if I create another buffer, like in this particular case, if I use instead of 2000, if I use 3000, right? So I am using 3000 and make it run. Now, the size of the buffer has quite substantially increased. So on the basis of the distance you provide, your buffer will be is created. Okay. So now in the same way, you can do it for a line feature. So again, if I import a line feature, so yeah, so I have a line shape file with me. I'm just adding it and uncheck all this. So this is the line feature that I have. And on the basis of this line feature, you can also create the buffer. So for example, go to the vector and then go to the buffer layer again. So now here in this particular case, the input layer should be line shape file. And again, you have to provide some distance. So again, I am providing a values like 1000 meter and click on run. So now buffer has been created around the line feature. Okay. So in this way, you can create buffer for point and line feature, but you cannot create any buffer for polygon feature. You just create buffer for point and line feature. And what is the purpose of doing this? As I have already mentioned that if you want to assess the flood proneness of a particular river, then you just provide the value up to which you want to assess. Then buffer will automatically created around the river. Or if you want to analyze the service area of a particular road, then again you have to provide some values up to which you want to assess the service areas. A buffer will automatically create. Now, the next thing that I will share with you is the cliff. So in the previous time, I clipped a vector layer from a raster layer. Okay, in the previous case, from satellite image. So satellite image is a raster layer, and from the satellite image, I just clip a vector layer or vector feature, polygon feature. But if I want to clip a vector feature from another vector feature, how can I do that? So just for doing that, you just go to the again. You just go to vector option, and here is the option called clip, right? So just click on clip option, and then you have to provide the layer you want to clip. So I am just first I will import the layer and then I will show it. Yeah. So I am importing the layer which I want to clip. So I have a shape file with me, that is the CD block of Hooghly district, and I have already shared all these layers with you. So CD block of Hooghly district, I'm adding it. Yeah. So this is a polygon feature or polygon layer. You have to import another layer on the basis of which you want to clip. So now I am just importing another area of interest. Yeah. So this is again another polygon that I have created, and this is my study area or area of interest. For example, I want to extract this particular portion from the background portion, from the map of Hooghly district. So how can I do that? Go to the vector layer. From vector layer, go to geoprocessing tools and then clip. Provide input layer as CD block, because from this particular layer we will clip, and the overlay layer should be your area of interest or the polygon layer that you created to extract the CD block. And now you have to provide a folder on which you want to save your file. So for demonstration purpose, I am not adding it. Just click on run. And now you can see that this particular portion or this particular polygon that I have selected to extract is getting extracted. Now, if you go to the open attribute table, you can see that within this particular polygon, how many blocks are there. So if you zoomed it, there are several blocks that are part of this polygon. And if you click on the attribute table, you can easily see that
Sir, we
these are,
see the
yeah,
attribute.
yeah, this is the attribute table. This attribute
So
table
we-
I am showing you.
Huh.
Now, you can see, so these are the different blocks that part of this polygon. If I close it and open the attribute table of the entire district, then there are total 18 blocks are there in the district. But here only few blocks are there, because within this polygon few blocks are there, and that's why in the attribute table only these blocks are showing which are part of this particular polygon. Okay. So again, I am repeating this process. Just first you have to import the two layer that you want to extract. I'm sharing with you the screen. So first you have to import the layers that you want to clip. So in this particular case, this is the map of Hooghly district that we have digitized. And this is my area of interest. And I want to extract this particular portion of AOI from the Hooghly district. So to do that, you just go to the vector option. From vector option, go to the clip option. Then provide the input layer as CD block, because from this particular layer only we will extract. And then overlay layers would be your area of interest layer or your study area. Then click on run. And now you can see that this particular portion has been clipped successfully. Okay. So now the next step is, so what is the purpose of doing clipping? For example, you have a national park or you have a forested area and you want to study a particular portion of that particular forest, right? So just you need two polygons. One is the whole entire forest area, and the second one on the basis of which you want to extract the forested area. Now, that is the third important tools that are available under vector geoprocessing tool is intersection. So intersection actually shows you the overlapping portion of the two polygons. If I show you in the software, then I'm removing this particular portion. So again, I will import another area of interest. Yeah. Adding it. So now you have two area of interest, and these two area of interest are overlapping with each other. Few portion of the polygons are overlapping with each other. So in case of intersection, whenever we execute the process intersection, only this overlapping portion will be highlighted. Now see, vector. From vector, you go to the intersection, provide input layers. So first I will provide AOI and then the second layer AOI2. You can do it alternately, no issue. And then click on run. Now see, only the overlapping part of these two polygons has been intersected successfully. And if you go to the open attribute table, you can see that areas are mentioned for two polygons, because we have used two polygons, and that's why this overlapping portion is consisting of two polygons, and that is why the area is showing that ID1 for polygon AOI1 and ID2.
Sir, go to
Yeah.
table.
Yes, yes. Sir, are you asking any question?
No, we don't see the attribute table. I think
Yeah,
we'll have
yes,
to
sir.
stop
Yes,
sharing.
yes, sir. I'm sharing. Now I think it is visible. So here the area for both the polygons are available. So this is for AOI and this is for AOI2, because this overlapping part or this portion is consist of two polygons, right? And that is why in the attribute table, two areas are showing. One is for AOI1, another one is for AOI2. Yeah. Now, again, we will learn another geoprocessing tools called union. So in case of intersection, only the overlapping part of the two polygon is getting highlighted. But in case of union, instead of the overlapping part, the two polygons highlighted simultaneously. How? Now see. If I remove this intersection layer, yeah. Again, just go to the vector option. From vector option, geoprocessing tools, and then here is an option called union. Now again, I will provide two layers. One is AOI and another one is AOI2. Okay. Now I will just click on run. And you can see that two layers added with one another. And if you go to the attribute table again, see, I am sharing with you. So this is the attribute table. So in case of intersection, only the overlapping part of the two polygons is highlighted. But in case of union, two polygons added with one another. And this is the attribute table for union. One is for AOI1 and two is for AOI2. So these are the few geospatial tools or geoprocessing tools that we frequently use to make any kind of spatial analysis. There are several other tools also, but actually these tools we use very frequently. For example, buffer. If you want to create multiple buffer, you can create it. So I am showing how do you create multiple buffer. But in this particular option, geoprocessing tools, only buffer is available. But if you want to create multiple ring buffer, then just go to the processing tool From processing tool, go to the toolbox option, and if I remove this particular one, then go to the processing toolbox, and a dashboard or dialog box like this will open. Just search on this dialog box buffer. And you can see that here several buffer options are showing. And one of the option is multi-ring buffer, right? So if I click on this multi-ring buffer, but to do that, first you have to import the line feature, which I want to use to create this multi-ring buffer. So just I am importing the line feature from my computer. Yeah. So this is the line shapefile that I have created in the previous class. I have imported it in QGIS environment. Now I will create multiple ring buffer on the basis of this particular line feature. So input layer should be line shapefile. Number of rings you want. So now I am providing 5 rings, right? And you have to provide distance between rings. So now I am providing distance for each ring is 500 meters, for example. And click on run. Now see. This kind of buffer has been created. If you make it hollow, then it will be more convenient to see. So as I have provided input for 5 ring has been created, and the green color, actually light green color, this is my actual line feature, and I have created 5 rings from this line feature in both sides, right? So in this way, you can create n number of buffer on the requirement, on the basis of the requirement of your study or purpose. So these are the basic fundamental tools that are available under QGIS, and you can use of this tool for making spatial analysis. Buffer, cliff, dissolve. Dissolve is another tool that's are available. And if I show you the dissolve option, then again I have to import some another data set. Yeah. So I have another data set with me. In this particular case, I will use this one, adding it. If I remove all this, layer. Actually, this is a quite large layer, and that's why it is loading very slowly, because thousands of polygons are there in this particular layer, and I am showing you. So this is another district of West Bengal. This district is Bardhaman district, as sir have already shown you some images of Bardhaman. So now if I go to the attribute table, you can see it will take some time because this is quite a large file. Yeah. Yeah, you can see more than 1 lakh features, 1,95,000, 2 lakh. So 3,33,000 polygons are there in this particular map. So, and that's why, yeah. And for each of these polygon, there are some IDs, right? And grid codes are there. And lots of polygons are there. You can, if I show you, I'm sharing with you the attribute table. Yeah, you can see that lots of polygon are there in this particular map. And there are 3 columns. One is ID, another one is grid code, third one is class name, right? So the purpose of using dissolve is that there is an option called grid code. And for each feature, like agriculture is denoted as 5, agricultural fallow is denoted as 6, likewise drainage is denoted as 2. So I will provide some instruction to the software that all the polygons with the similar grid code make it a 1 polygon, right? By using the dissolve option, you can do it. How? Now, go to the vector. From vector, geoprocessing, if I showing you, yeah. So go to the vector, geoprocessing tools, and dissolve option. Now from dissolve option, just provide the input layer that you want to dissolve, right? And you have to provide a dissolve field also. So here in this case, I will provide grid code as my dissolve field because I want the feature with similar grid code. I am providing the instruction to the software that please make a class of all the polygons which has same grid code. Now click on OK and run it. What happened? Just a minute. Vector, dissolve, LULC, dissolve field, person, grid code, select.
Monil, it can create a problem because the database is quite huge, isn't it?
Yes, yes, sir. Actually, there is
But
some
this is the process.
geometry.
Basically,
Yes,
this is
yes.
the process.
Yes,
Monil,
yes,
you can
this-
do one thing to make it easier. You can just
Hmm.
show it by the buffer. If you have done the buffer,
Yes, sir. Yes,
Just,
I'm just showing you.
the attribute table will not come properly, but they will have an idea of what.
Yes, sir. So,
Just open the buffer window and then you can.
yes, sir. First, I am importing the data set. So, I have a data set with me, hospital data. And now I am creating a buffer again. So, by creating a buffer, you just go to the geoprocessing tools, then provide input layers. And now in this case, I am providing a value of 2000. And now click on run. So, a buffer of point layer has been created. Now, again, I will go to the geoprocessing tools and go to the dissolve option. Yeah. And here I will provide the input layer as buffered layer, right? And click on run. So now you can see that all the buffers,
These are
yeah.
results.
So this is the method of dissolve. The buffer has been created, and here the intersection between two buffers has been merged with another. So if I go to the attribute table,
The attribute will not come, Monil,
yeah,
actually.
yeah. So this is the process of doing dissolve, and I have already shown you that how can you make a dissolve or how can you use this particular option. So these are the different geoprocessing tools that you can use for any kind of spatial analysis on the basis of your study requirement. But these are the tools we use for spatial data analysis.
When is it done? I mean,
Yes, sir. For today.
okay, then I will show you them. Show them a paper.
Yeah, yes, sir. I have some maps which I want to show.
Oh, please, please,
Uh,
please,
yes.
please, 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 please. Otherwise, I will show the Holocaust paper. I will show.
Yes, sir. Actually, this map I am showing. I have.
Well, have you told them what is the reason for doing buffering?
Yes, sir. Yes. Hi. So this is the presentation.
No, no, share the entire window. Otherwise, only the
Yes, sir.
previous window is
I'm just
displaying.
showing you. So now, these are the different maps that I have taken from a paper, and by visualizing this map, you can understand. So these are the different sub-center location or health center location, and this circle actually represent the buffer, right, or area of influence of each of the sub-center. In the same way, in the next class, I will show you some method of interpolation on the basis of point data. So actually, these are the interpolated map. And again, here in this map, by visualizing this map, you can understand that we can use this GIS environment quite robustly. Here again, these are the different maps that have been created by using this GIS platform. And you can also create this kind of map if you have the data set with you, point data set. And I will show you in the next class that how we can create an interpolated map by using point data set. Sir, if you have
Well, I'm just
something-
showing them. I'm just showing them how to take it.
Yes.
I'll just show you. I'll show the theoretical process.
Sir, if you have anything to
Now, basically, these are discrete data. It will be tough to interpolate, so that.
yes.
Okay, well, please stop your presentation. Then I'll just show the interpolation, and that should be the last thing to do.
Okay, sir.
Manil, my screen is visible.
Yes, sir.
Okay, thank you. So this was the paper actually from which we have taken these maps. So this is showing the sub-centers. All the layers are given over here. These are the block boundaries or the taluk boundaries. Actually, this is the district boundary. And then there are the rivers, then there are the roads, and then there are the sub-centers. And from the sub-centers, this is something well, statistical data is of two types. Obviously, one is known as the discrete data, another is the continuous data. So in case you have a continuous data, we can go for a process which is known as interpolation. But basically, I'll just show you the theoretical practice of that, because interpolation is related to some physical database. Upon those analysis, some transport analysis has been done over here. What is the transport network that they are having? And then this buffering has been done to show the zone of influence of a particular hospital maybe, and whether there has been any overlap or there has been any intersection and any point of union in between them. Say, for example, among the health centers, if there is a private nursing home, and what is the zone of influence for that. And again, the zone of influence can be divided into categories. There is the first zone of influence, second, third, fourth, etc. So that's what the objective of buffering is. Again, I can give you a robust example of buffering done in India. 5 years back, I suppose, there was a law passed in the Supreme Court that wine shops should not be located within a particular distance from the national highways, I'm repeating it, wine shops should not be located from a particular distance from the national highways. So it is not possible for the administrators to go through the every roads and then identify that this is the kilometer, that is the length, and the wine shop should be removed from there or not. But the best way of doing it was to digitize all the national highways of India. And say, for example, if the order was such that the wine shop should not be located at a distance of 1 kilometer from a particular road, then after digitizing all the national highways, if we create a buffer of 1 kilometer, and again we create another layer which contains all the wine shops of India, so it will be a point layer, and we overlap them. And obviously, we will very easily identify that which are the wine shops which are located within a kilometer of 1 kilometer from the national highways, and thereafter they were being removed from there. So this is how GIS is being used in different forms and facts. Well, this is a Thesian polygon, again showing the zone of influence of the health centers. Okay, just the final thing that I'll show you is that another important thing is this topology. This topology is something while digitizing something, say for example, I am digitizing. This is a road, say for example, these are roads and these are nodes. And I started from here. I started digitizing, and I go to the left of the road from here to here. So once I digitize it, the road will be created. And say for example, Moinul has digitized just the reversed way. So started from here and digitized up to here. So I digitized in this manner and Moinul digitized in this manner. So we should be very careful while digitizing. It should be, if I am digitizing a polygon, say for example, it should be either in a clockwise direction or in anti-clockwise direction. Or if I'm digitizing the roads or rivers or anything, whatever may be, other than the point features, so that digitization should be going in a particular direction. Because if I am digitizing from here to here and I'm giving a query that all the shops or all the health centers located to the left of the particular road or the left of this particular river are going to address this particular thing, then if I digitize from here to here, then all the health centers will be located in this part. And if Moinul has digitized from this to this, then all the health centers will be located from, on this part only. So the reverse phenomena will come into play. So it's basically important that while I'm digitizing, I cannot be very random in nature. So it should be either anti-clockwise. In digitizing, again, I'm repeating, in digitizing a polygon, it should be either clockwise or anti-clockwise, so that everything, when it takes place, when I'm applying any query to this, to the software, it takes place in a particular direction. And when, in case of a linear figure, in a linear stretch, when I'm digitizing something, it should be in a direction. Say, for example, I'm digitizing right from south to north, or from north to south, or from east to west, or from west to east. So it should be in a single oriented direction. So this is one thing. And the final thing is that sometimes we go for interpolation of data. And the interpolation of the data, basically, it is a continuous. Now, vector data are basically discrete data. So, for example, if I take this as a vector, okay, so here is a point, here is a point, here is a point, here is a point, here is a point. So these are basically discrete data. Say for the number of beds in a particular hospital, you cannot interpolate that. You cannot interpolate that. No, you cannot draw any kind of conclusion for it. But when there is a continuity of the data, say for example, there is a raster data like this. This is a pixel. And say, for example, we are getting the height of the particular area from the mean sea level, say, for example, and we are moving in this direction. So while moving, and if I can locate some points where with the help of the GPS, say, for example, I collect the altitudes of that particular area, then what we can do is that we can go for the interpolation of that particular data. The interpolation, the formula is like this. So to interpolate, what we need is the value, Z is the value. That is, what is the elevation? So the elevations over here are 12, 11.4, 10, 10, and 9. So a summation of that divided by the distance. Say I want to interpolate for a point, a particular point located just in between. Say for this point, I want to know that what is my elevation. It's an unknown point. So if I want to know the elevation of this particular place, we'll be going for interpolation of the maximum number of nodes we are having. So the two simple things are required. One is the elevation data for this particular case. Another is the distance data. So the simple mathematical formula, summation I is equal to 1 to n. That means n means the number of data you are having over here. So Z divided by D, and then again summation 1 by D. So you make it, you will get it. So you'll get the interpolated data. So that is how the interpolation is being done. But basically, these are continuous data. Say, for example, again, if I say we are having air pollution in particular areas, air pollution. Say in Kolkata is around 184 square kilometers. It's now around 204 square kilometer area after 3 wards being added to it. Previously, it was 141 watts. Now it's 144 watts. So I have some, I have some stations which measures the air pollution. So it's a 200 square kilometer area. So one single point is not going to give you a very particular data. So say I have 1, 2, 3, 4, 5 points. They give you the data regarding the air pollution. So just take the parameters, say any parameters, a particulate matter, PM10, PM2.5, nitrogen dioxide, sulfur dioxide, or whatever kind of data you want to fetch. So take any one parameter, have the values for these, say nitrogen dioxide, say over here, and you want to interpolate that. I want to get the data for here, whatever you want. So just identify the location that what to interpolate, or even you can interpolate for the whole raster. In fact, for the whole raster, if you want to interpolate, you just give the input of these two data, that is the value of the nitrogen dioxide and the distance from them. Just do it. You will get the data for the whole raster. In fact, there are processes of interpolation which are known as kriging, interpolation, IDW, etc. That is inverse distance weightage method. So there are several ways of interpolation. And specifically, you can go for air pollution in your case, and then after you can again conclude with some correlations of the medical parameters. So here I will stop. Even when you stop. Yes.
So may I ask a question about that air pollution thing?
Yes, sir. Please. This session, this last 25 minutes will be only for discussion. If you have anything, if you please ask us.
Yeah. So what you're saying is, can we predict the pollution level at data points where we don't have any values?
Yes, sir. Yes, sir. Actually, see, sir, what is happening? Say, for example, any meteorological data, say rainfall, say temperature, say air pollution. Now, these are not discrete data, isn't it, sir?
Right.
So these has got a continuity of its own, and this will have a slope of its own. That means, say for example, this red patch area, say here are some industries, okay?
Right.
Here are some industries. And this area, which is actually a green patch, say, which is showing a value of 9, these are vegetated areas. And these are the areas which is having lots of industries, say for example. So it's very obvious we can expect that the sulfur dioxide level of these areas will be quite high. So if I want to get the total data for this particular area, that what is the amount of sulfur dioxide that is remaining, or that is existing in the atmosphere over this particular area, we just have to have the data points. Say for example, 5, 6 data points. You have to have some data, otherwise we cannot do it. You have to have some data. Say for these five positions of air pollution, you have data for sulfur dioxide, nitrogen dioxide. You can even have some data for temperature. You can have data for pressure, or whatever. You just go to QGIS, you just interpolate it and
So, but my question is, the rate of decline of that pollutant level would depend on which pollutant we are talking about, right? The bigger particulate matter, the smaller particulate matter, the rate of decline from the source of pollution, like the factory, right? So the rate of decline of that pollution with distance would vary for each different type of pollutants, right? So
thank you for your question. See, this is already drawn over here. Actually, sir, can I ask you from where you belong?
So we are in Pune, and in fact, something.
In Pune, sir. Pune. Okay.
Yeah.
Say for example, any parts of Himalayas, say Mount Everest. Okay. So the height of Mount Everest is at around 8.8 kilometers. Right. And you just come 100 kilometers away from Mount Everest to say parts of Bihar, or just southwards, say parts of Bihar or West Bengal. So the place I am sitting right now in Kolkata, the average height of it is around 8 meters from the mean sea level. Only 8 meters, sir.
Right.
And the height of Mount Everest is, say, if I draw a straight line from Kolkata to Mount Everest, the height of Mount Everest is around 8.8 kilometers. Okay. So if a normal statistics, if I don't use any statistical methods, if I use my normal brain, now I am giving you the example of this particular thing. Say this is the height of Mount Everest, and this is Kolkata where I am sitting. Fine.
Right.
So you say Siliguri. You know Siliguri, sir.
I've heard the name, but no, don't
Siliguri. Or
exactly
say it's a Siliguri is like okay. Then consider Bombay and Mount Everest. Say this is Bombay or Pune, whatever, and this is Mount Everest. So the height of Bombay will be around again 10 meters. Mumbai.
Right.
Height of Mumbai will be around 10 meters, and height of Mount Everest will be like this. So
Right.
any part in Madhya Pradesh, if I draw a straight line, if I just interpolate joining a straight line, what will happen is that parts of Madhya Pradesh, parts of Maharashtra will be having height of around 3 kilometer, 4 kilometer from the base of the sea. But it is not so. The actual
Right.
height will be maybe 30 meter, 40 meter, 50 meter, other than some mountains.
Steepest decline is close to the Mount Everest.
Yes, actually. And therefore, this method is known as IDW, inverse distance weightage method. So actually, the curve will be like exponential curve.
Right.
So the closer you move to the source, the decline will be much steeper as compared to as you move away from the point.
So that's what my question is like. So for some particulate matters, they won't travel too far, right? So they will decline very rapidly.
Yeah.
But lighter matters, they can go for several kilometers.
Say particulate matter 10 and 2.5.
Right. So
2.5 will not travel much.
Right.
Sorry, 2.5 will travel much. 10 will not travel much.
10 won't much. Yeah.
So yeah, in that case, what will happen? This data case, this 12 and 9 will not be a sufficient data. You have to have some intermediate data for the decline that you were saying, sir.
So for in Pune, if we have to do that, I mean, we only have, I don't know, 12, 13 centers for detecting air quality.
Yeah.
Only 12, 13 monitors across all of Pune. So we need
13.
I think so. Yeah.
Okay.
So if there are such few centers, that is not enough data to say. So I can just talk directly about the study that we have. So what we are planning would be to have participants that are households, right? So we are looking at pollution exposure of each household, and those households are randomly distributed in the entire city. Now, just based on these 12, 13 data points, it would be quite challenging to predict their pollution exposure, right? So is there a way around it? Can statistics alone, this prediction alone, help us? Because if we
what is the parameter, sir?
So all these pollutants that you talked about, so if we talk about these pollutants, is there a reference or database that we know the rate of decline with distance?
No. There is not a specific reference that I can give you, but I can tell you one thing. See, to draw a line, we need at least 2 points, right?
Right.
So when you are having data set in between,
right.
So I mean 13 points. Well, if you don't have, you have to do it 13 points. Now, if you install some instruments, are you planning to install some instruments on the households?
So that's what we are
on the
trying
roof of the household, say, for example.
So like the sample size would be quite high, right? So the cost would be prohibitive.
Yeah, the cost will be a difficult one. That is the problem we face in a project.
That's why we were wondering, like, if there is any statistical.
There is another thing which is known as kriging. This is another thing which is known as kriging.
Right.
Okay, you can search for this kriging in your in internet also. But kriging is a very good one for identifying what is the rate of fall.
Okay.
This is a semi-variogram. This works out, but the problem is that for performing a kriging, you need a huge database.
Right.
You need a huge database. But this one, what I was just explaining, this IDW, you can even go for this. You can just go to interpolation and you can look for several kinds of interpolation are there. This IDW work with a data set which maybe I don't know whether 13 is sufficient. but maybe insufficient database it can work out with. But Kriging is one of the very good statistical tool for doing that. But the problem is that the Kriging needs a good data support.
Sir,
So what is the
sorry.
area of Pune? What is the area of Pune? Hello.
Sir, sorry to interrupt, sir.
Yes, sir.
Sir, can we use Aloha software, sir? We use this Aloha software for how much extent the chemical or how much extent these gases or vapors have gone to this much distance.
Any other kind of surveys?
Not survey, sir. Aloha software, sir. Aloha.
Aloha.
Ah, yes.
Sir, I have not used this actually.
Sir, Aloha software is like means how much extent the contaminant has gone in the atmosphere, like that.
It was in case of air pollution.
Ah, yes, sir. It's regarding the complete contaminants. Means it is
So I don't know
from
regarding the software, sir. I don't know regarding the particular software.
means
If you text me,
it is-
I can just look at it. But
Yes.
this is the fact is whatever software we might use, but you have to have some kind of data to interpolate it. Now, and these are the
Ah,
basic principles of interpolation. I mean, whatever software is there, you cannot go out of this actually, sir.
yes, sir. It is like modeling, sir. It is like modeling area locations of hazardous atmospheres. We
No,
call
you can
it
also develop models through this also. You can
Yes.
also develop models through this also. We have done a paper on LST, that is how the land surface temperature is changing over these areas. Okay, land surface temperature.
Okay.
For nitrogen dioxide, I have not done it specifically for nitrogen dioxide, sulfur dioxide. But what we have used is the interpolation of it, because that is the
because
only source of data we have.
actually the
And sir,
software remains-
and one thing I can suggest that since you were in Pune, I mean, somebody was talking regarding research in Pune. There are a lot of data in, I mean, IMD can provide you with some kind of data. I don't know whether they can provide you with this contaminated data, but IMD has got a lot of data. IMD is-
Actually, in our states or AP, we had some incidents from LG Polymers. I think you might have about LG Polymer incident. The styrene gas has means in the night time it was as an accident it came out. So
Okay.
our government people, they use this Aloha software to give the compensation to the families. Means how much extent the gaseous cloud has gone, how much kilometers did it travel, because without latitude, longitude, and how much what you are telling about the sea level, we have to enter this data. So then only it will model and it will create a
Actually, sir, that is what I'm saying. You
Yes.
have to have some kind of data now, isn't it?
yes.
Otherwise, see, these are the processes of interpolation. The software, see, software, we people develop software, sir. The name can be different, but we people develop software.
Actually,
So
it is,
this
actually, this one is like official, sir. It is from US EPA, means United States Environmental Protection Agency. Aloha is
Okay.
official thing from the US EPA.
Okay.
That is the thing.
So I just wanted to give you an exposure of it, actually, what you can do through interpolation, but just be clear about the fact that whatever data you are working with, you should be in a continuous mode. It shouldn't be a discrete data. With the discrete data, we cannot go for this interpolation of this kind of things.
Yes, sir.
In
For
terms of
continuous data, we can go for it.
So in terms of distance, suppose we want to install select number of stations for monitoring.
Right.
From your experience from past projects, do you know like within how much distance for air pollution we can have a reasonably good prediction? Like every how many kilometers? So for example, we randomly select households across Pune. So after we know where they are on the map, so like
So see that the best method that can be given, is using random sampling.
Right. No. So when we have random sample, we have selected households, right? Now we know where they are.
No, I am not telling that to select the
random
samples
sample
for
for pollution.
households, but I'm
Pollution.
just asking you if you can select, say for example, if you have selected the randomly, that means you have gone through the random table.
Right. So monitoring stations picked randomly, like locations randomly, is what you're saying. Instead
Sir,
of
two things, sir. One is selecting something randomly. I mean, is it
I
statistically random or it is only random?
So I understood random sampling, but so what you are saying.
Random sampling in terms of distance, sir. I want to say. Say
Okay.
if the source point is one, say for example, the source point is single, then
Right.
you can go for a buffering kind of thing.
Right.
But if the source point is multiple, say
Hmm.
multiple industries are there and they are located in different areas of Pune.
Right. Right.
So in that case, it is better to identify a particular center for that. And after identifying, we can take random distances. I mean, statistically random. It's not only selecting this household and that household, not that random, but statistically random. If you take any statistics book, na, at the back of the statistics book, you'll find a random table for that. 2-digit random table, 3-digit random table, 4-digit random table.
Yeah,
With the
sir.
statistical randomness will give you the best data set.
So actually the households are, the characteristics of households are a bit non-random based on our research question. So households would be non-random. So, but what we want is like in terms of expenses to get reasonable prediction, because we cannot have monitoring station outside every house that we select.
Right.
So within how much distance in your experience you have seen that you get reasonable prediction of pollution exposure of, so we have like say 100 households randomly scattered in an area, right? So if it's like a 5 square kilometer or 10 square kilometer, now how far a monitoring station has to be from
Sir,
all
this is
households?
very tough to answer without seeing the area. Because
You
I'm
said
giving
13
you an
is too few.
example.
You said
Say-
13 is too few. So
No, sir, I'm just giving you an example. Say, for example, you want to measure the pollution of 4 industries located at a distance of, say, 1 square kilometer, within a distance of 1 square kilometer. Fine.
right.
Now, your question is that from that particular 1 square kilometer, should I place them at a distance of 5 kilometer or 10 kilometer like this?
Right. To get the next data point, basically.
Yeah, right. I got it. But the problem is say, for example, these particular industries are polluting the environment with some, say, nitrogen dioxide, sulfur dioxide, methane, whatever. Now, say you are placing these instruments at a distance of, say, 1 kilometer. Say you have got the project cost permits you to place 5 instruments. So you're placing them for 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer. It might happen that the 4th one is giving you a very high data. And maybe our road is located close to that and several vehicles are running through it every day.
Right.
So without observing the map, sir, say for example, what we prepare in a geodatabase, what we prepare the basic layers, road layer, built up area that I have shown you just today, that how to prepare a land use map, right? So this built up area, vegetation, water body, the integration of these things and then going for a modeling, I think will be giving us a better results. Sir.
So have you used land use regression model LUR
Land use regression model?
for this kind of prediction?
Yes, sir, every time we do it.
Okay. Okay, sir.
Each
So,
time the last day I will show you the portal. There is a portal known as Bhunidhi. Okay. Today I can also show you, but it will take some time. You have to create a user ID and password for that. What happens is Bhunidhi is a portal created by Government of India, where you will get 8 portals within that, and from there you can download a lot of data, sir. I
okay.
promise you there is so much of data that you cannot even use it.
Okay. So
There is
maybe
so much of data.
I won't take up too much of other people's time. Maybe I can speak with you offline.
No, please.
Separate discussion about this.
Okay, you can call me. That is not an issue. But
Yeah,
till now also we have got 9 minutes left.
Sure.
Anything more for anybody? I don't know whether we have been able to create any kind of interest for you, because this is absolutely different subject altogether.
Sir, I have one question, sir.
Ask, please, sir.
Sir, till now what we had done is mostly we had like prepared a line, line vector and all through
Yes.
with the help of a map or some kind of raster data. Okay.
Right.
So, like for example, if I am seeing a road on a Google map, it is not appearing on that Google map, or say I don't have any like raster map for that road. Okay. So what I do is I will get a geo coordinate like lat long for every alternate at a regular interval while traveling on a road.
Absolutely.
So can I plot a line vector with the help of
Absolutely, sir. I'll show you something. I've shown you today also. I'll show you this one, please. Thank you for the question, first of all. See this one, what we have prepared. The last slide was on this. So this was something we did in 2018. Just the day before also I came back from field. Actually, I was late on that second day by 15 minutes because I was in field. See this one. This is the existence of a particular, say, actually the Bay of Bengal, okay? The Bay of Bengal over here. And I want to see that whether there has been any change of the coastal line. So there is no raster for that. There is neither any road for that, neither the Google will help me. So what we basically do, we walk with the GPS. Just take a waypoint, start walking with the GPS, and we'll take some waypoints in between, end in a particular area, in a particular point, and you can mark it in the Google Earth.
Okay, sir. So with that
Say
waypoint,
for
we will
example,
mark
sir,
in
say,
Google
I
Map.
say, for example, you live in a remote area, okay? You live in a remote village, and there is a road, which is a Kacha road. And you want to map that Kacha road, and that road travels for 5 kilometers. Now, it's difficult to walk for 5 kilometers for you. So what you can do, you can start your car or bike, whatever. You take a waypoint on your GPS, place it in your car, just travel to that particular road. Where the road ends, you take another waypoint and you just close it. Come back home. There is a software which is this one. Google Earth Pro. Okay.
Yes, sir.
This is easily downloadable, no issue. This is Google Earth Pro. Now, see, I'll show you something. These are the GPS points. Okay, these are the GPS points we have taken. We're working in the foothills of Himalayas. So these are the GPS points we have collected. These dots you can see. If I close this, places and borders, you can see it very easily. So these are the GPS points we have taken. So I was walking in an alluvial fan in North Bengal in the Himalayas. Okay, so these are the GPS points that we have collected. So similarly, just if you have a GPS or say even the phone, I don't know whether every phone is going to work out. Just connect it with the USB. Go to these tools and see here is GPS. Okay, so once you click on that, you can import the waypoints, tracks, and routes. So the way you are going through, you can just import it over here. Okay,
Okay,
you can just import it over here and you can see that where we are actually. Say even with the help of this particular, with the help of this particular software, say for example, I want to visit Ladakh. So LADA, and I want to see how the terrain actually looks like over there. Say, go to Ladakh, just give a search, and it will automatically fetch you the location. And see the clarity. This is what is known as spatial resolution.
yes, sir.
This is what is known as spatial resolution. Okay, so the clarity is quite high. So you can obviously understand that what kind of area it is. Its vegetation is quite sparse. Its terrain is quite tough, etc. So you can get a brief idea from this particular thing and in which part of India it is located or whatever. Or say, for example, you are traveling by a road and the road is like this. I'm digitizing. This part need to be moved a little bit. So I'm traveling by a road and see here also we can create line points and polygon. Okay. So by this one I can create a polygon over here and just you can name it. You can use this even your children can also use it very easily. Say the polygon A and I want to have the what is the total area. So I'll go for the measurements. There are several units. miles is not used nowadays. If I use kilometers, so and square kilometers, so the total area is around 161,527 square kilometers. So this is the total area in this case. And say again like this, you can draw lines. Say for example, I am drawing a line from here to here, from there to maybe coast of the Odisha. And again, I want to name the path. So let me name the path as AB. And again, I want to get the measurement. So it's 1,203 kilometers. And if I save it, it will come over here. And one interesting thing I'll show you. Now, if you want to see that how the altitude varies according to this line, then just go to the elevation profile. And this is so actually this is how the elevation changes, or this is how even the air pollution also changes, in fact. But obviously that PM 2.5 and PM 10 are going to travel different distances. Again, at the very same time, sulfur dioxide and nitrogen dioxide are going to travel different distances because of the different molecular weights they're having. Because the molecular weight of sulfur dioxide and nitrogen dioxide are not going to be the same. So you can just see that at how much distance, how it is traveling. The arrow is also going up and down. So what is the elevation at a particular area? You can find it out. So these are the things we can do by this. So anyway, I suppose it's okay today. And finally, for the next day, the last day when we are going to make, I'll stop sharing. The last day when we are going to meet, we will provide you with some very basic things, maybe creating a buffer or clipping, or maybe digitizing a polygon or digitizing a line or a point. So that should be your assignment, and you'll be provided with 1 hour time. So the first 1 hour will be your assignment. It will start at 7 o'clock, and up to 8, you will have the assignment that whatever we have discussed. I don't know again whether it's of any way helpful to you, or it's any way found any interest in that. Maybe a physical mode would have been more interesting. But on that particular day, we'll be providing you with some georeferenced files, with some chef files maybe. And we will request you to just perform any kind of thing that, very easy things that we will give you. To just have an assignment so that you will be having some better confidence in future. So thank you for today. May I leave? Anybody is there from IPH?
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Sir.
Okay, thank you. Thank you.
Thank you,
everybody.
sir. Good night, sir. Thank you.
Good night. Good night. Good night.